You know, every time you look up and see a plane in the sky, you're actually watching the finish line of this incredible high-stakes relay race. It's a race you probably never even thought about, but it's happening constantly, every single day, to keep flying safe. And the baton in this race? It's all about data.
And in this race, the baton is everything. We're talking about aeronautical data. If that baton gets dropped, or even just slightly fumbled during a handoff, the consequences for air safety could be, well, they could be catastrophic. All right, so how does this race actually work? Well, it's got three main legs, each with its own team of specialists. It all kicks off with data origination, then it moves through processing, and finally, it ends with publication and use. Every single handoff between these stages has to be absolutely flawless. So let's meet the runners. Okay, so the race starts right down here on the ground. The first runners out of the blocks are the surveyors. These are the folks meticulously mapping everything: runway coordinates, the height of obstacles, terrain features. Right alongside them are the procedure designers, the architects who draw up the precise flight paths that planes follow. They're the ones who create the raw data. This is the very beginning of the baton's journey.
Then comes the first handoff. That raw data baton is passed to the second runner, the Aeronautical Information Service, or AIS. Now, these guys are basically the central hub for this whole operation. They take in data from all these different sources, they check it, they organize it, and they format it into one single standardized language that the entire aviation world can understand and use.
And here we are, the final leg of the race. The perfected, standardized data is published and handed off to the end users. And we're talking about the pilots sitting in the cockpit, of course, but also, and this is just as important, their flight management systems. Those are the onboard computers that use this data to navigate the plane with incredible precision. This is the finish line, where that data brings the flight home safely. So, this relay race we've been talking about, it has an official name, the Aeronautical Data Chain. The ICAO manual, which is kind of the rulebook for all this, calls it a complex sequential flow with manifold actors. What's really interesting, though, is that the manual's scope really only covers the process up to the point of publication. Once that data is out in the world, any further processing by, say, an airline or a software company falls under a whole different set of standards. It's a whole ecosystem.
Now, you just can't have a race this important without some rules. We're talking strict, non-negotiable rules to make sure that data, that baton, is never, ever compromised.
And here they are, the 6 core rules right out of the ICAO playbook. You've got to ensure compliance with national standards and protect data integrity like your life depends on it. You have to build your processes with risk awareness from the ground up and use multi-layer logic checks to catch any weird discrepancies. You need to have tight control over the software tools you're using. And finally, you need complete audit trails, so every piece of data has a clear, traceable history. Every single runner in this chain lives and breathes by these rules.
But where's the race most vulnerable? Where's the baton most likely to get dropped? It's during the handoff, specifically when that data has to pass from one organization to another, like from a private company that did the survey to a government agency, like the AIS. This is where things can get messy. This slide just lays it out perfectly. The problem is that when you're moving data between different teams, they might have different systems, different formats, and that's where data can get corrupted or just plain lost. So, how do you fix it? Well, 2 things. First, every single organization involved has to use a standardized quality management system, or QMS. Second, they use what are called service-level agreements, or SLAs. You can just think of an SLA as a super detailed contract that spells out exactly how the handoff is supposed to happen, the formats, the deadlines, the verification steps. It's the official rulebook for passing the baton cleanly.
This all leads to a really fascinating and, honestly, a super important question. If everyone follows their quality management system perfectly, does that automatically guarantee a safe outcome? In other words, is a good race, one that checks all the boxes, always a safe race? The answer, well, it might not be what you think.
And here's why. It turns out that quality management and safety management are 2 very different things. A quality management system, the QMS, is all about the process and satisfying the customer. Did we deliver what they asked for, on time, in the right format? Check. But a safety management system, an SMS, is focused on the outcome. It asks a totally different question. Is this data actually safe for a plane to use? So for example, a customer might ask for a really simple, clean-looking chart, and you deliver it perfectly. That's high quality. But what if that simplification accidentally left out a new radio tower? See? It's no longer safe.
And hey, don't just take my word for it. The ICAO manual says it directly.
And this is such a powerful idea. It is possible to meet customer/stakeholder requirements while not meeting the objectives of safety. This gets right to the heart of the problem. You can make the customer happy, but still create a huge risk if you're not also focused on objective safety.
So what's the big takeaway here? It's that quality and safety aren't the same thing, but they have to be partners. They're complementary systems. You need a fantastic QMS to make sure your processes are consistent and reliable, but you also need a rock-solid SMS to make absolutely sure the final product is fundamentally safe to be used in the air. Having one without the other is a gamble nobody can afford to take.
Every single flight you see is the result of this invisible relay race, where every single handoff has to be perfect. It kind of makes you wonder, doesn't it? What other complex systems in our daily lives, from the power grid to the financial markets, rely on a similar, unseen chain of perfect handoffs just to keep us all safe?